T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 miles per hour. Tower clear.
Okay, we got a roll program. Neil Armstrong reporting the roll pitch program. Last 30 seconds. Roll complete and mission program.
In less than 3 weeks, humans are going back to the moon for the first time in 53 years. The rocket is already at the launch pad. The crew is ready. Let me walk you through exactly what's about to happen. The Artemis II mission isn't just another space mission. It represents humanity's return to deep space after more than half a century. The last time humans left low Earth orbit was December 1972, during Apollo 17. That's 53 years ago. Everyone who walked on the moon is now in their 80s or 90s, or has passed away. An entire generation has grown up never seeing humans venture beyond Earth orbit. But this mission is different from Apollo in crucial ways. Apollo was about proving we could get to the moon and beat the Soviets. Artemis is about proving we can stay there, build infrastructure, and use the moon as a stepping stone to Mars. This is the difference between planting a flag and establishing a presence. The 4 astronauts on Artemis II will travel further from Earth than any human has in over 50 years. They'll see views of our planet that only 24 people in history have ever witnessed. And they're doing it to test every system we'll need for permanent lunar operations. The Artemis program, named after the twin sister of Apollo in Greek mythology, is a symbolic passing of the torch from the Apollo era to this new age of exploration. These missions are part of NASA's plan to establish a sustainable human presence on and around the moon. Then use that experience to send humans to Mars by the 2030s or 2040s. Here's how it breaks down. Artemis I, completed November 2022. Uncrewed test flight of the Space Launch System rocket and Orion spacecraft. Flew around the moon, tested the heat shield during re-entry, proved the basic systems work. Success, but revealed some issues that needed fixing. Artemis II, this mission, February 2026. First crewed flight. 4 astronauts will fly around the moon on a free return trajectory, meaning if something goes wrong, physics will naturally bring them home without needing engine burns. This tests all life support systems, crew interfaces, emergency procedures, and validates that humans can actually survive the journey. Artemis III, currently planned for 2027 to 2028. The big one. This will land astronauts on the lunar surface for the first time since 1972, specifically targeting the moon's south pole, where we know water ice exists in permanently shadowed craters. The crew will use SpaceX's Starship as the lunar lander. The key difference from the Apollo missions is the sustainability which NASA aims to achieve. We're not just visiting, we're staying. This is NASA's long-term plan. But right now, as I'm recording this, the rocket for Artemis II is already sitting on the launch pad in Florida, and the clock is ticking toward liftoff. The Space Launch System rocket and Orion spacecraft rolled out to Launch Pad 39B at Kennedy Space Center on January 17th to 18th, 2026. The same historic launch pad that sent Apollo 10 and multiple space shuttle missions to space. That slow 4-mile journey from the vehicle assembly building marked the beginning of the final countdown. Here's what happens between now and launch. Engineers are currently performing final system checks and running through launch procedures at the pad. But the most critical test is still ahead. The wet dress rehearsal, scheduled for no later than February 2nd. During this rehearsal, NASA will load over 700,000 gallons of supercooled liquid hydrogen and liquid oxygen into the rocket's tanks, run through the entire countdown sequence, and then drain it all without actually launching. It's essentially the final exam before the real thing. If the wet dress goes smoothly, the primary launch window opens February 5th through 11th. Each day in that window has specific launch times dictated by orbital mechanics. The Moon needs to be in exactly the right position relative to Earth for the trajectory to work. NASA is currently targeting February 6th or later, though they've been careful to emphasize no earlier than language. Translation: delays are absolutely possible, and weather adds another layer of complexity. Unlike robotic missions, crewed flights have much stricter safety requirements. The Atlantic Ocean recovery zones where the capsule would splash down in an abort scenario need to be calm. Wind speeds at the pad must be within tight limits. There can't be lightning within a certain radius. Any of these factors could scrub a launch attempt. If they miss this February window entirely, the next opportunities come monthly based on lunar positioning. But each delay doesn't just push back Artemis II. It cascades through the entire Artemis program timeline, potentially delaying Artemis III's lunar landing and everything that follows. Now here's the critical thing to understand. Artemis II is not landing on the Moon. The crew will never set foot on the lunar surface, so why do it at all? Because before you send astronauts 240,000 miles from home and ask them to land on another world, you have to prove that every single system works with humans on board. Not mannequins, not simulations, but real people. The first system under test is the Artemis crew's life support. Orion must keep 4 astronauts alive for 10 days in deep space. That means recycling air, managing carbon dioxide, supplying water, regulating temperature and humidity, and handling waste. Artemis I flew with sensors and mannequins. Artemis II is the first time these systems are stressed by humans, eating, sleeping, exercising, sweating, and breathing. Then there's radiation. Once the spacecraft leaves Earth's magnetic field, the crew is exposed to cosmic radiation and potential solar particle events. The astronauts will wear sensors to measure exactly how much radiation they receive. Data that's essential for planning longer missions. Communications are next. When Orion passes behind the far side of the Moon, it will lose contact with Earth for about 30 minutes. During these blackouts, the crew must confirm the spacecraft can operate fully autonomously. The astronauts will also test manual flight controls. Orion can fly itself, but in an emergency, humans must be able to take over. The crew will manually fly the spacecraft at multiple points throughout the mission. One of the biggest tests is the heat shield. During Artemis I, Orion's heat shield experienced more erosion than expected during re-entry at 25,000 miles per hour and 5,000 degrees Fahrenheit. For Artemis II, NASA is using a modified skip entry trajectory, where the capsule briefly skips off the atmosphere before final descent. The crew will validate that this new approach works exactly as predicted. Finally, the emergency procedures. Abort scenarios, backup systems, contingency operations, all of it will be rehearsed. It's far better to uncover problems on a flyby mission than during a lunar landing. Think of Artemis like this. Artemis I was the uncrewed test. Artemis II is the crewed test flight. Artemis III is the mission that counts. You don't skip the middle step when lives are on the line. Every sensor reading, every crew report, every system test on Artemis II feeds directly into the final preparations for Artemis III. If something fails, better to learn that circling the moon than standing on it with limited options to come home. This slow, methodical approach is exactly what kept Apollo astronauts alive during humanity's most dangerous missions. NASA learned those lessons the hard way, and they're not about to forget them now. Artemis II isn't about planting flags. It's about making sure that when humans return to the moon, they come home safely. Because exploration isn't about rushing forward, it's about surviving long enough to keep going. If you enjoyed this breakdown, subscribe to Byte Brain for more educational, mind-blowing space and tech content, and stay tuned, there's a lot more coming.